We receive a few questions in the chat, so do not hesitate to put more questions if you have. So now is the time to the Q&A session, and I'll have a look on the Q&A panel. So perhaps the first question is, do you consider free-floating stability for the TLP for the towing, or does the concept require offshore lift to add the top side? Okay, so for that, perhaps Jeremy, if you want to answer.
Yes, I can answer. That's something we have worked on also with Jean-Sébastien, one of our colleagues who is here. What we have considered for the installation is to have free floating towing of the TLP with the topside lift in a near shore, hopefully sheltered area. That's the base case scenario for the installation.
Okay, thank you, Jeremy. The second question that we receive is what statistical value we have considered for the semi-submersible and also TLP for the maximum acceleration, so means that the root mean square of the MPM or something else. Regarding the semi, perhaps Johan, if you want to answer.
Yes, I can answer for the semi. So we run a frequency analysis for calculating the motion of the semi-submersible using a hydrodynamic software called HydroStar. And the results we have from this is a most probable maximum that we compare to the criterion in the end.
Yeah, okay. Maybe I can answer
TLP,
for the TLP. It's the same. It was MPM acceleration, and we were quite above, well above the criteria, especially for vertical acceleration. Yeah.
Okay. Thank you. I receive other question. Regarding the consideration of superconductivity cable for the export, perhaps for you, Jan, do you initiate any work? It was not in the frame of AFOSS-DC to consider the type of technology, but perhaps you have other initiative at RT?
Yes, exactly. We have the supramarine project, which address directly this aspect. So yes, that's a solution on the table. We are investigating on that. Yeah, and so if you are interested to know more, please check supramarine project.
Okay, well, perhaps in terms of maturity, is not so high at this stage, but yeah, a lot of interesting investigation regarding this solution for the future.
Yeah.
Okay, as you have the floor, Jan, perhaps another question for you. During your presentation, you balance, in fact, the and you talk about a green range of water depth for which we consider we don't know yet if we need to consider a bottom fixed or floating substation. Do you want to share any preliminary range of depth for which we need to shift to one to the other? Yeah, if you want to share that.
Yeah, so what I can answer for the time being, so that's difficult to answer because it's exactly what we want to tackle with our investigation. So a bit too early to answer of this, but just to give some point on that, what we are investigating today, as you understood, it is mainly the HVDC floating offshore substation, so a very consequent asset in terms of weight. And that's a very important parameter to consider when you want to check the applicability on a given water depth. And then the study that we are engaging so far, the range of water depths that we are checking is between 100 meter plus up to 160 meter. Which is basically the range where floating offshore substation HVDC would be moored in our country.
Okay, perfect. Thank you, Jan. Perhaps just a precision. Jeremy, can you just confirm if we found a significant difference between the topside weight design for semi and TLP? Could you perhaps detail?
The topside weight, no, actually it was the same. Yeah, exactly the same design was taken into account for both floaters. Yeah.
Okay, you just adapt, in fact, the transition piece as required in order to fit with the floater
Exactly,
constraint in design. Okay.
We adapt the transition piece, and of course, maybe what you see in the picture you share, we use a simplified version of the topside for the basin test because it's not the purpose to have the typical topside design. But for the design and calculation phase, it was exactly the same, yeah, for the topside.
Okay. Another question regarding the topside design. Perhaps for you, Johan, did you in fact consider all the equipment required during the topside design and general arrangement, and not only to consider the centralized power of all the wind turbine, and also all the heating, all the accessories, ventilation, everything have been considered? Can you just confirm what have been considered during the topside design?
Yes, I can confirm everything has been considered, all the auxiliary equipment and everything for the yes, everything mentioned has been considered in the general arrangement of the topside.
Okay, thanks. Regarding the basin test and associated analysis for you, Jeremy, you present some results regarding the fitting of the RAO obtained based on regular wave and numerical model developed in frequency domain, of course, but have you also analyzed other non-linear motion result as the TLP is a non-linear problem?
Yeah, yes, I haven't developed completely, but we have analyzed, and especially on focused wave with the help also of a researcher from Ifremer and NSTA. Maybe something we can continue. And on those particular focused wave, we have identified some linear resonance regarding springing and ringing.
Okay, because you present, this is the reason why you put accelerometer on side the makeup of the substation in order to highlight and to be able to record this type of phenomenon in Tandun and or in Cologne that can appear. Okay,
exactly, yeah.
And as we talk about the campaign test, I have another question. Have you put in place, if I remember well, some probe inside the column in order to follow the free elevation of the free surface, the elevation of the free surface? Do you observe some phenomenon like, don't know, elevation, sur-elevation, run-up, or something like that, or slamming?
Yeah, that's something we pay well attention to. We have placed, I think it was 8 capacity wave gauge to have free surface acceleration. We did observe some run-up on the column. Normally, we did not observe real slamming on the top side, but yeah, that's something we pay well attention to in the basin test campaign. Yeah.
Okay, thank you, Jeremy. I just check if there are other questions. Yeah, perhaps for you again, Jeremy, have you some preliminary cost impact analysis regarding the LCE reduction between the both design?
That's a tricky question. Probably I will not be able to answer it fully. What we can say in terms of dimension is not the same shape, but might be comparable in terms of material cost, I would say. Because the draft is higher for TLP, the installation might cost a bit more. I'm afraid so. Apart from that, I will not be able to give you much more detail on the costs.
Okay, we understand this. Another question regarding the type of anchor that we consider for the TLP.
Yeah, I've checked also Jean-Sébastien. I think it's a pile anchor, or I think maybe driven pile anchor that we have considered.
Yeah, but I think too, but it was not the main objective. It was not in the frame of this project because AFOSS-DC was also objective was to perform a preliminary design of the overall system, but not to focus on specific solution. And for example, for anchor solution, we not analyze deeply in detail several solutions as we have not have a complete geotechnical data of the soil at the location that we select. So yeah.
It was not the purpose. Yeah, you're right.
But not the purpose, but we extract, of course, the tension obtained, and for further work, we have the input data in order to be able to do this type of analysis based on the soil data, as I highlighted before.
Maybe Nicolas, I read again the comment I just I answered before.
Yeah, please.
I would like to correct my answer because so the top side about the centralized power supplies for wind turbines. So in the top side we have we consider everything all the auxiliary equipment for the top side, but not for the wind turbines themselves. So we don't. I think we don't have this centralized power supply for wind turbines inside the substation.
Okay.
And maybe one of the first comments was also for the semi-submersible related to the light draft of 9 meters. So yes, even with the top side installed on the semi-submersible, we can reach very low drafts because with for example with the towing draft of 14 meters, we still have a lot of ballast inside. So yes, we can reach low drafts even with the top side.
Okay, thank you, Juan, for the precision. Just have a look on question again.
There was another one at the beginning related to the model analysis.
Yeah, but it was for the fault. But please, Johan, go on.
Yes. Well, so there is, of course, there is no issue with 1P or 3P because there is no wind turbine. So, but in comparison, the constraints are really about the maximum acceleration allowable, and maybe also with more high frequency that would lead to some fatigue issues, but that's not something that was in the scope of this project. So maybe for more detailed work in the future. Yeah.
Yeah. Thank you, Johan. I have a question also for you, Johan. You mentioned during the presentation that the overall size of the semi-submersible obtained due to constraint in terms of stability and other things exceeds your actual capacity at Chantilly Atlantic, do you investigate other solution or ID in order to be able to build the semi-submersible at your shipyard? Do you have some idea to do that in France or in Europe? Yeah, if you have some things to share with us about that.
Yeah, well, it's not the priority number one to build the floater within Chantier de l'Atlantique. And well, the most simple solution would be to build it in a dry dock with the dimensions that allow this. So a bigger dry dock. So the preferred scenario would be to build it in the shipyards with the right dimensions to build it inside. So in another bigger shipyard in Europe or Asia.
Okay. Jan, for RTE, I think you have a question for you. Is a single line setup available for high current voltage system? Are you already some idea how the HV interconnection is arranged, or some interconnection is still an open air installation in the current concept which are built? Do you have some reaction about that?
To be very honest, that's an open question still. For sure, in terms of offshore substation, let's say the philosophy employed by RTE is not to put it in open air. So we have yes arrangement already in place for bottom fixed offshore substation, and I think we will apply the same philosophy for floating one.
Okay, thank you, Jan. Perhaps another question for you that I have. You mentioned also during the presentation that you initiate some work with supplier on critical system identify like HVDC GIS, dynamic cable DC also. Do you have at RT, do you have a timeline in order to de-risk this type of system? Do you have a vision at this moment for that? How you plan to work on this several aspects in order to be able to build this type of floating HVDC substation in the coming years, decade? I don't know if you can give us some timeline, perhaps. Could be interesting.
Yeah,
for
sure.
everyone.
Thank you for the question. Yeah. So yes, indeed, we have several initiatives at RTE in order to de-risk the different technology that I have mentioned. So namely, DC dynamic cables, HV equipment on top sites. So we are building with FEM and a Chantier some another project involving this type of qualification, mainly focused, as I mentioned, on this DCGIS valves, DC dynamic cable, transformers. What we want to address with this new initiative is really to get the overall picture of the OSS and having in the team the actual people that are delivering the equipment, so the manufacturers. That's a given project which is named RODE, and I hope we will be able to communicate very soon on this. It aims at addressing all these aspects in the following 5 years. And parallel to this, also we are working with our supply chain with other manufacturers in order to de-risk also the technology that I have mentioned. So as I mentioned, the timeline is in the following 5 years to be able to have a better certainty on the feasibility on the floating offshore substation HVDC for the French environment and coast.
Thank you, Jan, for this view of the following action. Very interesting. So as we have no other question, I will close this Q&A session. Thank you again for the presentation, all the answer to the question, to all the speakers today. As you mentioned, Jan, at France Energy Marine and with all our partners, we'll continue research and development effort on these topics and to de-risk and to make this floating substation real in the coming years and decade. We really believe that improving the reliability and optimizing the design to reduce the cost of floating substation will also be a key for the development of the floating wind industry in France, in Europe and worldwide. So if you are interested by detailed result obtained of AFOSS-DC or other link project, do not hesitate to contact us.